So this video lesson is all about solving equations, and in particular we're talking about solving equations using addition and subtraction. Now we talked a little bit earlier in the year about what equations are, what the solutions to equations are, the types of things that we're after when we solve equations, and starting in this chapter we're going to look at a more rigorous, detailed way of solving equations that we can then extend into solving pretty much any equation that we come up with until about Algebra 1 or geometry, where a few other things start to get added to it. But the point of this video is not just finding the solution. The point of this video, and for the entire rest of the chapter on solving equations and inequalities, is the process that we use to solve the equation. So before we get started with anything going on in this chapter, remember, the process is as important as the solution. In this case, the process may even be more important than the solution, and we'll talk a little bit more about that in class. So first, I want to go over a quick vocabulary review. You don't have to write any of this down. These are things that you have in your notebook and we've looked at already before. Some important vocabulary with equations. Equations themselves, it's what we get when we take two expressions and set them equal to each other. A few examples of equations are here: x plus 17 equals 12, 3x plus 1 equals 16, 3x equals 21, things like that. And when we work with equations, our goal is often to solve them or define the solution. The solution to the equation being the specific value you can substitute in for the variable that makes the equation true. We can choose any value that we want when we're talking about an equation, but there's only one in the ones that we're looking at that are going to make the equation true, so that the equal sign really does say that these two expressions are equal to each other. If they're not equal to each other, it's still an equation, it's just false, and false equations aren't particularly helpful for us. So let's take a look at a specific example of an equation and go through what a rigorous, detailed work process that keeps in mind all of the things that we're looking for looks like. So the idea behind solving an equation is we're going to use the example of x plus 12 equals 17. Go ahead and pause the video and solve this equation mentally. Figure out what the value of x must be to make this true. Jot it quickly down in your notebook so we can have it off to the side, and then come back when you're ready to move on. So for many people looking at this, you probably looked at it and thought, okay, well, we need a number that's being added to 12 to make 17. And so the calculation you did in your head was, well, okay, well, if we take that 12 away from 17, we end up with 5. So our solution has to be x equals 5. And it turns out that when you're doing the mental math here, you're already doing half the work. Notice I said half. It's not the entire work that you need. It is half the work of rigorously solving an equation, just by recognizing that that's the calculation you're going to do in your head. And the reason why it's only half the work is because it only deals with one part of the equation. An equation, when two things are completely equal, can be thought of like a scale. The equation always has to be kept in balance. If we do something to it so that the left side no longer equals the right side, then we've done something wrong. But it turns out that there are a lot of different ways that we can manipulate equations and work on equations so that we can keep those two sides in balance, but also do some pretty powerful calculations to move forward and eventually find the solution. So there are two big things that we're after when we're solving an equation, at least particularly right now in this class. When we solve an equation, what we really want is something that looks like x equals. So our big goal is to isolate the variable. That's what that's called, isolating the variable on one side of an equation. But as we go through and we isolate the variable, we have to make sure that the equation stays in balance. And so what we're working on for this chapter is not just keeping the equation in balance, but showing that the equation is still in balance. And like I said before, once we've gone through and we've worked on all of these skills and all these processes, you can apply them to increasingly difficult types of equations, and eventually, just with a few things that we learned over the next week and a half or so, you'll be able to solve a wide array of potentially difficult equations. And so showing that the equation is still in balance essentially means making sure that what you do to one side of the equation happens to the other. For example, if we were to take a scale that were in balance and add 5 pounds to one side, we would have to add 5 pounds to the other to make sure it stays in balance. On the same token, if we were to take 10 pounds away from one side of a scale that was in balance, we could keep it in balance by taking 10 pounds away from the other side. So there are lots of different ways we can think about that. But right now I'm going to ask you to pause the video and write down a few different things. You're essentially going to write down this entire bottom part of the screen right now, and I ask you to wait until this point to write it down so that we could get through a number of those concepts. So pause the video, write down everything in the red box, all of the reminders, the scale itself so we can look at a visual for it, and then come back when you're ready to look at what it means to solve an equation that way. So as we said, our two goals are isolating the variable and showing the equation is still in balance. So when we're isolating the variable here, for the equation x plus 12, what we really want is something that's just equal to x. Now what I've done on the left side near the scale is to show an example of a few things that we could do to each side of the equation to keep them in balance. If we add 15 to one side, we just have to add 15 to the other. If we subtract 12 from one side, we just have to subtract 12 from the other. But we have to show, because that's one of our goals, we have to show that that balance is still happening. So to get from x plus 12 just to x, we need to get rid of that 12, because the 12 and the x are the two terms on the left side of the equation. Now we're adding 12 to the left side, so we can get rid of it by subtracting 12. Remember, addition and subtraction are inverse operations. And so adding 12 and subtracting 12 essentially cancels both of them out, and we're left just with x. Well, we've just taken 12 away from the left side of an equation, so now we have to take it away from the right side of the equation. And here, where we see 17 minus 12 equals 5, this is why the work that we've done before actually makes sense and gets to the answer. It's because when we do it to both sides of the equation, we're left with just x equals 5. So this step right here, this is what we are working on for the next week and a half, showing and understanding how to use that balancing step to move through different forms of the equation to get to where we want. And we can do that because of a pretty cool property of equations, which is called the addition and subtraction property of equality. I'm going to ask you to pause the video, write both of these things down here, and we'll talk about what it means when you come back. Essentially, what this property is talking about is saying that if you add or subtract the same amount from each side of an equation, you don't change the solution. And if you stop to think about that for a second, that is a really powerful concept. The fact that we should be able to manipulate on both sides of an equation, where the equal side really means that both sides of that equation are identically the same, and still create things that have the same solution, is pretty powerful. And it doesn't say we have to do the exact same thing to both sides. It says we have to add or subtract the same amount. And we'll get back to that later, particularly when we get into fractions and decimals. Essentially, if we add or subtract the same value from each side, the solution doesn't change. So we can go through and manipulate an equation in a lot of different ways, and create equations where the solution is entirely the same. Let's look at one more example of what that means now with subtraction, and then we're going to give some example problems for you to work on your own. Now, the left side of the equation that has x minus 12, we would love it to be just x. But right now, x has 12 being subtracted for it. The inverse of subtracting 12 is adding 12, and we would really love to get rid of that minus 12 so we can just see an x. Those two minus 12s and plus 12s cancel out, and we have just our x, but we need to balance the equation. Just adding 12 to the left-hand side sends it seriously out of balance, so we have to do the same thing to the right side. Negative 5 plus 12 is 7, so our solution is x equals 7. And in order to really show all the work for the equation, we need all three of these steps: the equation itself, the work that's balancing, and just x equals 7. I'm going to say this one more time because it's very important, and every year there are a few people who don't follow this. When we solve equations, simply writing the solution x equals 7 is not enough work. We must show the balance. And if you come into class and you don't show the balance, then you haven't really done the work to start working on these things for homework. So go ahead, pause the video, write this whole process down so that you can see the balance work and the solution, and then we'll move on to some practice problems for you. Okay, so we're ready to move on to some practice problems, and the important thing that we need to remember is that we have to show the balance on both sides of the equation in order to work on this process. So when you were working on these equations here, make sure that you're showing not just what the solution is, but also the balance work. And if you have questions about what that means and what that looks like, that's what we'll go over in class the next time you come in. So go ahead, pause the video, solve these equations, use the balancing work, adding or subtracting from both sides of the equation that we saw before to show the solution, and come back when you are ready to see the answers. So let's start with the equation in the upper left-hand corner. We see we're adding a negative 5. And there are two ways we can look at this. We could subtract negative 5 from both sides of the equation, because after all, adding and subtracting are inverse operations. So adding negative 5 and subtracting negative 5 clear the left-hand side so that we have x. Negative 5 minus negative 5 becomes negative 5 plus 5, because that's what minus a negative means, and we get x equals 0. The other way we can look at it in terms of seeing the plus negative 5 as subtracting 5 is one of the things that we'll look at in class. Moving down to the bottom left, we have x plus 15. We would love it to just be x, so we're going to take that 15 away. We're going to have to do it to both sides of the equation. And now we have negative 4 minus 15. Negative 4 minus 15 is negative 19. Notice that in solving equations, we're practicing and going back over all of those negative number operations that we saw before. In the upper right-hand corner, we're adding 12 to both sides to get x equals 28. That way the plus 12 and the minus 12 cancel out. And on the lower right-hand corner, we see x minus 9, so we add 9 to both sides to get rid of that and have x is equal to 4, because negative 5 plus 9 equals 4. So remember, the important parts of solving an equation rigorously, showing all the work that we need to start working on that process for solving equations, involves a lot of different things. We have to show that the equation is still in balance by showing the work on both sides of the equation, and our goal when we solve is just to isolate the variable, so we go from something where the variable is wrapped up in a number of different operations to just an x equals, or a y equals, or an n equals, or something like that.